Hello and welcome to MyWebUniversity.com, where I bring you online educational courses in computer science, IT, and DevOps. You can see under my Web University YouTube channel, I have more than 2,100 online videos. You're welcome to learn from them. There are online courses for free on YouTube. And also I have it on Dari language, which is about 506 videos. You could learn them in Dari if you speak Farsi, Dari. And if you speak English, there's 2,100 videos. At the same time, under MyWebUniversity.com, I have this book that I wrote online for you. And the name of the book is The Direct Path to Linux Ubuntu. It has 15 chapters, and every chapter is by itself is another book, a book. And then there's hundreds of thousands of technical documentation on this book that are all about Linux, Ubuntu, Linux Red Hat, Linux Rocky, Windows PowerShell, and Windows command lines, as well as chapter 2, 3, and 4 teaches you Linux Basic, Linux Intermediate, and Linux Advanced levels. All of these ones you can practice it online on MyWebUniversity.com by following these chapters. I don't want to go too much in detail on this book because I have a presentation to make. And let's get started with that presentation, which is installing PyInstaller module. PyInstaller module in virtual environment allows you to run your own Linux, Windows related binaries. So if you're on a Linux platform, you get executable link format or standalone binaries. And then if you're on Windows, you get .exec files, which is executable files. And how you make them, you have to install PyInstaller module, and you do it in the virtual environment platforms. And this video is going to be in English. At my Web University, I'm going to post it. Then I could make subsequent in Farsi also, and I'll post it at my Web University-Dari videos there. So to start with, let's go through a slideshow, and I'm going to show you what I'm going to cover under PyInstaller. And with Python, you have to first install virtual environment. The virtual environment allows you to just run it on a Windows platform or on a Linux or Mac, a virtual environment, which means that your environment is isolated to a virtual directory structure. In the directory structure, you have some options to activate the virtual environment and deactivate it. Whenever you do the virtual environment, it is going to be just more cleaner in terms of your system is not going to be cluttered with system related binaries. For example, if you have Python 3.11 in the virtual environment and you want to keep 3.12 on the system, they are isolated. They are not going to have conflicts. So no system clutters on the fact that you're doing virtual environment. At the same time, when you run the PyInstaller, you have to activate the virtual environment and do that one. Then you have an option to build your executable or executable link format on Windows platform. I'm sorry, on Linux platform. And Windows is .exec. So let's get started with that. This is a Python tutorials, and I'm going to install PyInstaller module, which is a module or library within Python and Python programming language. So you have to have Python or compiler, actually Python interpreter. Python interpreter is both functional and object-oriented interpreter. So once you install the Python interpreter, the current version is 3.14, but you might have it on your system 3.12. Anything over 3.6 will help you out to do this virtual environment and PyInstaller module. So building a standalone executable for Linux and Windows platform. On the Linux, I'm going to show you the Linux Ubuntu, and then also Linux Ubuntu is my web university is running on Linux Ubuntu. So if you're practicing chapter 2, 3, 4, you're basically running the command on my web server, and then the output is showing on your browser. Linux on a browser. How cool is that, right? So if you just practice it, you know this is really, really a powerful feature that I have made it available for you online for free. Practice those ones and learn it, and then hundreds of thousands of technical documentation. Plus, from there, you could just get to the entire internet, which you can have millions of other documentation available at your fingertips. So the fact that I'm going to cover a Linux virtual environment today, as well as Python installer, and on both Windows platform and Linux, that by itself is a lot of help, and that you can share with your loved ones, and they could learn it also. So virtual environment makes your environment much cleaner, isolated, and manageable. Meaning that if you have Python 3.12 and then an NumPy module and request module, PyInstaller module, then you can just freeze it and then give the readme.txt file into another person, and the other person could duplicate your virtual environment, and you don't have to worry about that directory is gone or deleted when you have basically the readme.txt file that to build it again. So why virtual environment? Why we use virtual environment? Keep your system clean, isolated dependencies per projects. So if you make a directory my project, and then your project you have installed, as I said, NumPy, pandas, and request, and other modules of Python. Every version, it is kind of meeting all the dependencies. They are isolated for that my project there, or my virtual environment that you have done there. And then also setting up the virtual environment, you create and activate the virtual environment. So when you create the virtual environment, you have to activate it. On Windows, it's a different way to activate it. You either have a PowerShell script.ps1 to run that one, or a .batch BAT file to do it. And on Linux, the .csh for C shell, and no extension, just activate, is for a bash. I will show you those ones. So installing PyInstaller, to install PyInstaller, basically is run the pip install PyInstaller, installing only inside the virtual environment, no system pollution, no system cluttering. And on Linux, you do build on Linux, generate executable link format standalone binaries. And this is very powerful, that you could just make out of your Python interpreter to just run executable link format or .exec on Windows. And that is a binary that is much faster in some sense, because it is standalone. You could just only ship the executable, and then you don't need the Python interpreter, because it's an executable for that system. That is whatever is the x86 platform or another platform, you build it for that one. The binary was for that register and CPUs. Build on Windows, generate a .exec executable for Windows. As I mentioned, on executable link format is the equivalent binary version of Windows.exec. Excuse me. On Linux, you have executable link format. And then option and tips, one dash file, icons, hidden imports, and troubleshoot. Excuse me. For the option for the PyInstaller, there's one option, a --1 file, meaning that create one file. You can use the -- icon to just create your executable with the icon and hidden imports and troubleshooting, dash names, and further information that I can show you later. So why use virtual environment? And the benefit of the virtual environment is a lot, and it's really good that it helps you big time. First of all, the big important thing is no system cluttering. Package installation only inside the virtual environment folder. Your global Python stays untouched. So if you have a Python version globally that everybody else is using it, and then for one developers, you create a virtual environment, this is isolated with the version that you install for NumPy, for request, for PyInstaller, for any pandas, any modules. That version is just for you. And then when you just are done with it, you can wipe it out and just create a readme.txt file out of the list of packages by doing a freeze. And then after that one, you just load that one in GitHub, the readme.txt, and then that's it. And you just recreate it again and again from that one. Your global Python stays untouched, so other users and global systems are not going to be touched with virtual environment. Peer project control. I'm sorry, per project control. Per project control is like, okay, the directory or peer, or I could say per in this case, whatever directory you created, that directory you have full control of what dependencies you want to install for what module. Each project gets its own exact dependency versions, no more version conflicts. That's so important, per project control. Reproducibility, share requirements.txt. This requirements.txt, I said readme.txt, I meant requirement.txt. This requirement.txt is the one, once you freeze it, you create this requirement.txt. Inside the requirement.txt, you have all the dependencies and version for this folder virtual environment. And then all you have to do is do the git push on this one, requirement.txt. You push it into the GitHub, and then after that one, you download this one and you build your system again and again. Can create the exact same environment. That's important. So if your system is sometimes not reproducible because you install Python with 3.12, and then maybe on a development machine that you ran these NumPy, they had 3.11 or another version, or Python 2, 2.7, whatever old version that the other machine was there, most likely you could not reproduce it. But if you just made the requirements on your install of a virtual environment, you just created this requirement.txt, and then this requirement meets all the dependencies that you have. When you just recreate the requirement.txt build, and then after that one, you're done. You just have all the dependencies, your system will reproduce itself. Save to delete. Once you are deactivating the virtual environment, it's okay to delete the virtual environment. You never push the virtual environment into the GitHub. You always just only push the requirements.txt. That's good enough. There's a .ignore file on the GitHub that you just put it, and if you just say don't do anything but requirement.txt, you push it, and then now you delete the virtual environment, just delete the virtual environment folder to completely remove all project packages. Then you can recreate it from requirement.txt. That's very efficient. So what are the prerequisites? The prerequisite, you have to have Python 3.6 and up, meaning that you could have Python 3.6, 0.7, 0.8, and up to 0.14, which is the current one, then you're all good. Anything over 3.6, you're good. So the way you check the version of Python 3.6 or PEP version, you say Python 3 -- version, or PEP 3 -- version, or PEP -- version. Any command that you say something like this, it will just give you the version of that binary or that executable, Python 3 in this case. And then comes with a very with virtual environment module built in. So on Windows, once you install Python 3, automatically comes with a virtual environment. On Linux, you have to install it. Available from python.org or package managers. You can use WinGit on the Windows to get it, or wget on Linux, Ubuntu, and DNF on Linux, Red Hat, or Fedora, Rocky. All of those ones uses DNF or YAM. Available for python.org and through packages. And then on Linux, no extra step is needed, but you need to install Python 3 virtual environment. You may not have this one by default. If you have not done it, then you have to do a sudo apt install on Ubuntu, sudo DNF install Python 3 virtual environment, and they get installed. On Fedora, the same thing, DNF or YAM. You use the package manager. On Windows is WinGit. And then once you install the virtual environment, then you could say apt install Python 3 virtual environment. This is actually on Linux Ubuntu. To install the Python 3 virtual environment, this one is going to allow you to just create a virtual environment on your system. But there's additional command to make sure that you can activate it. If you just did this one, you will not have the activate and under the binary directories. I'll show you the command that you need to do with Python 3-m, and then the module name, and then the name of the directory or project for the virtual environment. So on Windows, downloading Python installer from python.org, make sure that you add it on the path, and virtual environment is already automatically included. How to create and activate the virtual environment. So on Linux and Mac, it's very easy. You install Python 3.12. In this case, on whatever version you have, mine was 3.12. So I'm going to install Python 3.12 virtual environment module first by using the sudo command. The reason you need sudo, because without that one, it will give you anything when you do apt, it will just say, oh, the system needs your sudo privilege in order to just install it for you. So you have to do that sudo or become root first, and then run apt install Python 3.12 virtual environment. So with apt install, you can use any Python 3 binaries. So the name of the package usually will be provided. If you just didn't know it, you could do apt search, also apt list, apt show, apt info. A lot of those commands will help you to find it. In order to navigate to the project folder, you have to make a my project or whatever directory on your home directory. This tilde meaning that is for your home directory. So in this case, cd to my _ project directory and the home of my user. And then after that one, this is the command I was telling you, that after you did the apt install Python 3, in order to have the activate in those PS1 and the Windows already has the activate.ps1 and activate.batch, as you can see here. But this is the command that if you don't have it, you can install it. Python 3-m virtual environment. This -m means the dash module. The module virtual environment, because you install it here, the virtual environment is now available for you to do it. This is the name of the folder. In this case, I said give it the same name as virtual environment. For short, you could say virtual environment, VNV, or MyV virtual environment, whatever name you do, you're fine with it, I'm fine with that. Activate it, and how do you activate it? Because this is C shell activate, and then you could say, if it's bash, and this is actually bash, so you could say source activate dot, and then that's on the virtual environment bin directory activate, and then you can also source activate.c shell.csh for C shell. And then your prompt now shows the virtual environment your username at the host name, and then so on, all the directory that you are there. On Windows and PowerShell, you cd to your project directory, whatever Windows directory folder you are, you go to that one, then you say Python-m virtual environment. So this is Python 3 or Python. If you have the name Python on Windows, you just type in Python, and Linux, usually, if you didn't have an alias Python for Python 3, it will just not work. So make sure that you create an alias that, to point to Python 3 by saying alias Python space is equal Python is equal in Python 3. And then here, Python-m virtual environment, and virtual environment is the name of the directory that you're creating. Then you cd to that directory which you created. There's a script directory on Windows, and then on the Linux it's a bin directory. That's a binary. This is also a scripts directory, similar to binary on Windows. The name of the file is activate here. Without the extension here is activate.batch. For Windows, command line, DOS command prompt, and for PowerShell commandlet is activate.ps1, which stands for PowerShell 1. So you do that one, and then you're good to go. And then at this time, you go to the next level, which is step 2, and install PyInstaller inside the virtual environment. This is important. You don't do it on your system level. You create a virtual environment, then you activate the virtual environment, then you install the PyInstaller inside the virtual environment that you just created. That way, your system is not cluttered, and it's clean, it's isolated into the virtual environment. You can destroy it in the directory afterward when deactivated, and created the requirements of text, and push it into the GitHub, and then all you have to do is rebuild it at another host. So the virtual environment, I'm inside the virtual environment. You can use pep. So once you install Python with the virtual environment, the Python and pep already comes in. Inside here, if you say pep -- version, it will tell you the version of pep that's available for that Python 3.12 version, for example. So you can say pep install, and PyInstaller is the name of the module inside the virtual environment. Now it gets installed. And then you can run inside virtual environment PyInstaller -- version to get your version of PyInstaller. And then if you need further help on how to create the standalone application for Windows or Linux, you can just say PyInstaller -- help, and it will give you all the syntax. The default syntax is very easy. You say PyInstaller and -- file, and then the name of your Python scripts, and then it will create by default that .exec and put it on the disk for distribution directory. However, you can say -- name and give it a new name. For your executable, you can say -- icon, -- console to create a terminal command line, and then -- no console to create a graphical or GUI kind of Windows silence mode and everything else. So there's a lot of option for this one. Make sure your prompt shows a virtual environment before running pep install. This ensures a PyInstaller goes into the virtual environment, not your system Python. This is very important. Always activate it inside the virtual environment. And then verify installation, so you can run the PyInstaller -- version, as I told you. You can verify what version you're running, and you might be getting it depending on what version at the time that you did it, 6.x or maybe whatever version, .x will give you the version number. Install your app dependencies. So if you have to do inside this virtual environment, NumPy or Pandas or other requests or any other modules, just install your app's own dependencies here by doing pep install, and then, for example, request is there, and NumPy, Pandas, and so on. Build the executable on Linux. How do you do it on the Linux? It's just simple, right? If you just say one file and then that's dash dash help will give you these kind of arguments, the options. So PyInstaller, the default one is dash dash one file and the name of your Python scripts. The directory that you're running this Python as source file is inside your virtual environment. You have this file, and then there should be a disk for distribution directory. The binary will reside here. It will get created under with the name my underscore app for executable for Linux. And then if you're on Windows platform, my underscore app.exec. But if you're on Linux platform, no extension. You could also give it with dash dash name and give it whatever name. You could call it Wahid or my app or app one or whatever. You decide the name, what it should be the executable. With with console windows, so there's a dash dash option, and here the default shows terminal output. If you didn't specify dash dash console, it is like this default one, but it is going to be on the terminal. No console is going to be a GUI, silently executable, no terminal pop-ups. This is important. So if you see the binary is silent, you make sure that it is a GUI option there for running it in the GUI. And then PyInstaller dash one file and dash dash name. This is the dash dash name. You could give it any name for this app. My app, you could say demo one, or you could say binary one, whatever name you want to give it, that's fine. But make sure you give it meaningful names. And then the executable, for example, here in this case, there's under the distribution, my underscore app. And if it is on Linux, on Windows, it would be my underscore app.exec. So executable link form binary, the executable link format binary runs with this name. By // you could run it with executable. Renames the binary to my apps dash dash name. You can name it anything else if you want. Just do that. Step 4, build the executable on Windows. On Windows is very simple also. PyInstaller dash dash one file, my app.py. And that's basically creating it with my app.py. And then you could also do PyInstaller dash dash one file dash window my app. This was a window app, basically ideal for GUI application like TK Enter. So this is a TK toolkit interface that is their TCL. This is another module in Python that you could allow you to do graphic dialog boxes, which stand for toolkit interface, TK interface. TCL/TK is the module, and then this is the interface, INTER. So when you do this one with dash window, it is going to create a graphical interface. This option, PyInstaller dash dash one file, it makes a one file kind of binary or standalone binary. Dash dash icon, you can give it an icon image, so your app is going to have a nice icon for it, and then attach the icon to the executable. And then all together, if you just do more options, you could give dash dash one file and then dash window for graphic, dash dash icon to attach the icon, and dash dash name to give the app an name, and then my app underscore app.py is your source code in Python. And then the executable on Windows is .exec here under the distribution. By double clicking it, because it's a executable, it runs on the GUI if it is a TK interface. Double click to run it, no Python installation is needed. So what is the virtual environment structure? Recommended project structure, usually you create a my underscore project. This is your project. Under that one, you have a virtual environment. and then all of these other subdirectories are getting created and files are getting created under virtual environment. So this is your virtual environment that has isolated packages, NumPy, pandas, anything that gets under a virtual environment. This is a very important project structure. You have to know the architecture, you have to know the structure of how these files are going to be available on the system. And when you have the requirement.txt, basically you don't want to just put this directory into the GitHub. These are a lot of packages that are unnecessary for you to put this one. But you can put the requirement.txt has all the binaries, which version of your source code is there, what are the icons, what is the executable, and then what is the executable. You don't upload it either, because you can always build it from the command line once you build the virtual environment on another system. So build, and this one is also under the build, there's a lot of the specification files that are just default for customization. You could do that. And it's my app underscore spec is the specification that I just mentioned. This is the executable file or executable link format in Linux. Never commit virtual environment. This one, you never commit it. If you commit this one, then you're just having so many junk on your GitHub. Don't do that one. Add it to the .git ignore file. So you put this directory on the git ignore, so it never, when you take a commit, you don't commit the binaries. Okay, it's huge and user specific. You don't want to do that one. Commit requirements.txt. The requirements.txt, once you freeze it, this requirement.txt has all the dependencies in it. What version of NumPy you have, what version of pandas you have, what version of Python you have, all of that is on this requirement.txt. This is your building the system. Run pip freeze and greater sign requirement.txt. So inside your virtual environment or outside of this directory, once you say, when you're in the virtual environment directory, you could say pip freeze, automatically reads all the versions and dependencies, and then it's going to write into the requirement.txt. This pip freeze is the command that you want to practice when you're creating your system to build it for later. Requirement.txt is the one. The .spec file, PyInstaller generates this edit for advanced configuration. That's when you do advanced configuration. And that this is your output, the executable or executable line format, .exec file, and it will reside here. So that's when your user are going to run that one for the binary. Useful option and troubleshooting. Some of these ones you can also get it from the --help. So --head and import, and then I just define it what it means here. --add data -clean and --clean. --clean is important that force a refresh rebuild. So if you ever say something that might have been not right, let me just do it. This is like the make clean, make clean, or make desk clean for distribution clean with building the system. This --clean of the PyInstaller will just rebuild all these files for you, clean it up. You can also do RM on the desk directory and the build directory, and just run the command again. It will just recreate those ones. Test before building. Run your app from the activate virtual environment first to catch any important errors early. And this is also important on Windows. Antivirus false positive. So PyInstaller, sometimes when you install any software on Windows platform, and then it's gonna kind of like detect it as if you have virus. But sign your executable or advise users to whitelist this name of the binary that you give them, because it's not a virus, it's antivirus false positive. However, on Windows, if you have not sign anything, it will just tell you that, oh, this system, it might be malicious code or something, because it is given a .exec file or .pdf or some other files. Sometimes Windows is kind of paranoid without being coming from Microsoft or signed by the author. So make sure you sign it or tell the users to whitelist it, because this is false positive. Unless you just wrote a code that maliciously wants to do directory delete or something, then you don't want to whitelist that one and you don't want to give it out to users. And deactivate the virtual environment. To deactivate the virtual environment, you just use the deactivate command. When done working, you do deactivate. So Python and virtual environment and Conda, they have this environment that you can run into a virtual environment, activate it, do your work, and then when you're done, create a requirement.txt and then deactivate it, and then remove the entire directory. And now you could use the requirement.txt to rebuild it. Your prompt returns back to normal. A quick reference for a cheat sheet on the Linux. Creating a virtual environment is easy. You just type in Python 3-m virtual environment and then the name of that directory where you create the virtual environment. So Python 3 is the binary for Python. -m means module, and then the name of the module that you had already installed. This one is called virtual env. This virtual env create the virtual environment, whatever name you get. Then once you create it, by activating this one, you go to this virtual environment directory under the bin on Linux, and then run the activate, which is the bash script, source it, and then if you are on C shell, you source activate.csh. And then to install the PyInstaller module or installing NumPy, you just use pip. Pip install pandas, pip install PyInstaller, pip install games, whatever the name of the module that you're doing, and in this case PyInstaller or pandas or NumPy or request, just replace the name of the module with that one. And then pip list will show all the modules that are currently installed. Pip search will search for the pip reinstall, and it will reinstall the name of the module that you ran for. PyInstaller -- version will give you the version, but in this case, if you say --1 file, notice this one -1 file, one file is one word, so it's not dash there. And then myapp.py, and then it will just install it. You can do PyInstaller --help, it will say all the syntax there. Deactivate is to deactivate this virtual environment. It's the opposite of activating. When you activate it, your prompt changes from whatever prompt you had to virtual environment, as I showed you, and like here. And this is for Windows, Python -m virtual environment, and then activating it, virtual environment script activate.bash. Then once you activate it, then you could just go run the .ps1 file, which is PowerShell activate.ps1 or activate.bash for Windows command prompt DOS. Pip install PyInstaller will install the PyInstall module. Pip install NumPy will install NumPy. Once you have all of that one, then if you have a Python script on that directory, you just say PyInstaller --1 file, my app, and then .py. And now under this directory, you will have a binary on Windows called this/myapp.exec. Or on Linux, it would be, after this one would be under the distribution, my_app. If you wanted to give it a particular name, you just say --name, and then you give the name after. So now you're ready to do the build. You create a virtual environment, install PyInstaller, and then build and distribute your app. How simple it is, 3 steps. You create the virtual environment, install PyInstaller, then use PyInstaller to create the one file and give it the distribution, the executable from the distribution to your users. A virtual environment keeps it clean. And --1 file bundles everything, built on a target operating system, whether you can do it on Mac or Windows or Linux. It is there. The distribution will have the binary or executable link format file, .exec file or executable link format. Well, users will run that one. Please make sure you like and subscribe our channel. We're not done here because I'm just done with the lecture. I'm gonna do a demo on Windows and Linux platform so you can fully understand how to do it. Okay, so let's get that done.